Welcome to lesson 14 of C++ programming language. In this video, we will study about operator associativity and precedence in programming language C++. So this is the plan. First, we'll see what is operator associativity, what do we mean by this, followed by operator precedence, then associativity and precedence table split into 3-4 slides, and then some example expressions and statements which explain the role of operator associativity and precedence, followed by a working example. Now we can understand operator associativity like a tug of war. You must have seen this or played also. So here on both the sides we have we have two persons or two teams, and there is a mark which the teams have to pull towards themselves. And here we have two marks, and any team or person who pulls this mark towards the mark which is towards their end is supposed to have won the match or won the war, tug of war, won the war. Okay, so every operator has an associativity. So if an operator binds first to the right side, or this side you can say first, it is known to be right associative. There are two associativities. Left associative, an operator can be either left associative or left to right associative, we call it, or right associative or right to left associative. And associativity establishes the order in which the operators of the same precedence will be evaluated in an expression. And what is operator precedence? Operator precedence is nothing but the priority assigned to operators when it comes to evaluating an expression. For example, in this expression a plus b multiplied by c, we know that b multiplied by c would be evaluated first, then the result would be added to a. In school days, we were taught BODMAS rule, that is bracket followed by off followed by division, multiplication, addition, subtraction, and so on. This can be understood with the help of a simple order of precedence in Bharat or India. In any government event or a function, the following is the order of precedence. First priority is given to the President of India, followed by Vice President, followed by Prime Minister, followed by governors of states, then former presidents, then Deputy Prime Minister. In official notification, it is 5A. Though this is not the constitutional post. It means whenever there are elections held, it is not essential to have a Deputy Prime Minister. This position may remain vacant. After this, Chief Justice of India as well as Speaker of Lok Sabha. In official notification, it is 6. So now Chief Justice of India and Speaker of Lok Sabha both have the same precedence, same priority. Now in C++ programming language, when you go through the second edition by Bjorn Stroustrup, go through pages 89-90, where operator precedence has been listed. Here you will find that post-increment, decrement, and pre-increment, decrement operators all have same precedence. But in number of books you will find, or number of places you will find that they have different precedence. So when I read the book by Bjorn Stroustrup, C Programming Language, 4th edition, pages 255 through 257, I found that post increment decrement operators have higher precedence precedence than pre-increment decrement operators. Actually, this book covers C++ 11 standard. So, in the new standard, order of precedence has changed. Not much new operators have been added, and precedence of pre-increment, post-increment operators have been made different. So one has to be very careful which standard your compiler is following, which standard is being followed by your compiler. Now let us see some operators, or rather all operators, their precedence and meaning, associativity. So this is new, added in C++ 11 perhaps. This is the lambda function. When you want to execute a piece of code without assigning any name to it, we use it. We'll discuss this separately in separate video. Then the parenthesized expression, both of them have highest precedence. Then scope resolution operator as well as global. So this is used very frequently in C++ programming language, and this will become clear when we discuss classes and objects and operator overloading, function overloading, etc. And this has left to right associativity. This also has left to right associativity. Then the member selection. So dot and this symbol. This symbol is made up of two symbols. Minus symbol immediately followed by greater than symbol, no space in between. Then for function call, then is the array index, then typecasting, and here is post increment decrement operator. Then type ID, what is the type of a data or object or a variable. We can come to know this at runtime. Then static cast, dynamic cast, reinterpret cast, const cast. We'll discuss them in different videos as and when required. Then size of, it is an operator as we have already seen in C language. Size of, it tells me size of a data type or a variable or a structure or a class in bytes. This is typecasting. There are two different places I have mentioned, and we'll see them. Okay, they're different usage, so they are not same, though the by word they have been written like as if they are identical, but they are not identical. And pre-increment decrement operators, unary, plus, minus, all of them are right to left. This is new operator. Okay, to create new block of memory, we use it new, and then delete operator to destroy the newly created block of memory. Then can expression throw, so no expression. Align off, we'll study them separately. Then the member selection. So this actually points to the member of a class or a structure. This also points to a member of a class or a structure, but here this symbol is nothing but a pointer, and this is the entity itself. Then the commonly used three operators, multiplication, division, modulus, they are left to right. Then addition and subtraction operators. Then shift left, shift right, then less than equal to, greater than equal to. These four have the same priority or precedence. These two have the same precedence, but they have the higher precedence than this. Followed by these two, equal to, not equal to. Then bitwise AND, bitwise exclusive OR, bitwise OR, logical AND, logical OR. Then ternary or conditional operator. This one is this has the associativity right to left, this ternary operator. Then these are perhaps 13. Yeah, sorry. These are 13. 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, and 13. Correct. So this is normal assignment operator. All assignment operators have their associativity right to left. Okay. Then sorry. add a sign, subtract a sign, multiply a sign, divide a sign. This is if both the operands are integer, it is integer division a sign, otherwise float divide a sign. Then mod sign, that is remainder a sign, bitwise AND assign, exclusive OR assign bitwise, bitwise inclusive OR assign. Then this is shift assign, okay, right shift assign, and this is the list. So here you have a list of expressions. Throw an exception. It means if there is an error which you expect, you can throw an exception. Throw is an operator, but it is normally used along with try and catch, which are nothing but the keywords. Last one is this comma, which is nothing but a separator. It is like in int I comma j, it is separating two variables of same type. It has the associativity left to right. Now let us see some expressions and statements. So here is an expression, a plus b plus c. What is the operator? It is binary addition operator. Not binary addition, it is addition, but we call it a binary plus sign. It means it requires two operands to work on. So here, since the addition operator has associativity left to right, then this addition operator would be applied first. So the sub expressions or expressions A and B would be added first, and then the result would be added to C. Now here's the problem is, standard does not say whether left hand side of this plus would be evaluated first or the right hand side of this plus would be evaluated. The standard is silent about it. Now suppose A is a sub expression and B is also an expression, A is also an expression, and they are using some variables which affect the other. It means it has a sub expression which uses some of the variables of the sub expressions of B. It means B and A and B themselves are expressions, bigger expressions. In that case, the result may be ambiguous, and it will depend on what compiler you are using, which compiler on which platform you are using. So the result would be compiler dependent. Though normally there is no problem, the result is identical whether it is A plus B. So whether you evaluate A first or B first. But if there are interdependent sub expressions, then the result would be compiler dependent. Similarly, in this case, it is more obvious. Here I equal to I plus 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 I. So now this operator would be applied after this assignment, but it has two operands, I plus plus and plus plus I. So if you evaluate this plus plus I, this value of I here would be different, and if you apply this post increment operator, then when it comes to this, it will find some different thing. You can convince yourself that under my compiler the result would be this because this is applied first, this is applied next, and so on, blah blah blah. But the result cannot be guaranteed. So it is our responsibility to write our statements and expressions in such a way that it is compiler independent. So never use this form of expression where a variable is used in more than one expressions, and evaluation of one expression or evaluation of the final result is dependent on the order in which the sub expressions are evaluated, and it is compiler dependent. Now the third one, we know that suppose this is the expression, I want to multiply two expressions rather, divided by the third one, which is logically equivalent to this, because the precedence of a star, that is multiplication and division, precedences are same. So here, since they are left associative, so in this case f1 and f2 will be multiplied, so this will be evaluated first and result would be divided by f3, or f1 divided by f3 multiplied by f2, absolutely no problem. But see what would happen due to the precedence and associativity and particular data. everything may seem to be fine, but still the program may yield wrong result, or result may be erroneous. So now let us see a working program. I have written a very small program. On the right pane, I have written the source code, and let me execute the program. Now this is simple. Let me scroll it, because this first line, IO stream, we know this, using namespace std, int main, opening brace, and so on. We know this. So let me scroll it up a bit so that you can see the rest of the code. Yeah, long double. I have declared three variables, f1, f2, f3 of type long double. Okay, and next one is I have assigned f1, this in scientific notation, 1.3 e to the power 28, f2 22.0, f3 7.0. You may immediately recall that in the previous video we tried to calculate the ratio of 22 divided by 7. So same values I have taken. Now I want to see the values in fixed notation. Okay, so now if I say cout f1, it has printed this. Now you can see here value is 1.3 multiplied by 10 to the power 28. So after 1.3 we must find all zeros, but it has printed these non-zero digits also. So I reiterate that floating point representations are not exact for every number. So it is clear here. So here 22.0, no problem. Here it is 7.0, absolutely no problem. So by default 6 digits after decimal point. Number of times I have said this. Now here it is printing the product of 2. Okay, so it is like this, and here it is printing f1 divided by f3, a division. So these two sub expressions I can see. Now I can see here, since both these expressions are representing logically the same expression, isn't it, in the previous slide which I told you. But you can see here the result here is this, and result corresponding to this cout is this. I can see, so it is up to this point. You can see here this, both are printing identical digits, but after this is, here it is 5, here it is 9, here it is 6, here it is 9, here it is 1, here it is 0. So it means just we change the order in which the operators are being applied, since one of the numbers could not be represented exactly, okay, whether it is a division or a multiplication, you are going to get the erroneous result or ambiguous result. We know that both these expressions are identical, so they should produce the same result. Okay, so there will be another example I have written afterwards. Now you see here, in case of int x, now here I have written intentionally 1 near to 5 as compared to the space between 1 and star. So now what do we think? 5 should be shifted towards left hand side once, so it becomes 10. 10 multiplied by 3, 30. It should result in a value 30, but it is here 40. Why? Actually, if you look at the precedence table, you will find that star has a higher precedence than shift left. Okay, though it appears I have written it like this, I have written it nearer to 5, but it is not like that. So star, that is multiplication, has a higher precedence than shift left, so this will be operated first. Okay, so 1 multiplied by 3 is 3, then the result would be the right operand of shift left operator. So shift 5 towards left 3 times, then this has the least precedence, so right to left. Okay, so 5 shifted towards left once, it becomes 10, 2 times 20, 3 times 40. So this is nothing but the 40. Now here x plus 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 x. What parser would do? It will read the longest string to match. So it will parse it as x plus plus space, then plus, then space x. So it means this one. But here again, this x would be evaluated first. I mean, this x plus plus would be evaluated first, or this x would be used first. This could have been written like this as well. If this is written like this, it means it is pre-increment operator. Okay. So in whether it is this form or this form or this form, I am using two expressions on both sides of plus symbol, one of the plus symbols, which is affecting the value of the other operand. So again, you can convince yourself that in my case, for example, I will say, okay, let me see. What is the value of x? X was 40 in previous statement. Now here x plus plus. So its value would be used first, then post increment. So it becomes, you can say 40, then add 41 to it. So it means this form, 41 to it. So it becomes 81, isn't it? So it is 81. Then here, what I have done? 81 it was 81. Then you say 81 is used, then incremented. Okay, so 83. You can convince yourself that your answer is correct, but it may seem to be correct under my machine. I am using compiler which is G++ under Linux, default compiler under Linux Ubuntu 22.04 LTS. It may also happen other compiler under other platform may give you the different result. So try to avoid this. If we want to force particular order of evaluation, then use parentheses appropriately. Same thing would happen here. I have enforced the evaluation of this. Okay, so this would be evaluated first, but again same thing is happening. Plus plus x. Now whether this will be evaluated first or this will be evaluated first, I have shown you part result in the sense use appropriately the parenthesis to avoid confusion. Okay. Now same thing here. Okay. So don't go for these things. Okay. Now here this is interesting. This value would be 4. Okay. Now if you remove, I have written here under comments, if you remove the parenthesis, then there will be syntax error. Why? Because shift left operator has higher precedence than this bitwise exclusive OR operator. So what would happen if you remove parenthesis? 5 would go with cout with this operator. But after this, when it is tokenized, you will find that it is a binary operator, bitwise exclusive or binary operator, but it would not get any operator to operate on the left hand side. It will get only one on the right hand side, isn't it? So it will be a syntax error. So it's better put it under inside parenthesis. Now more interesting result. Now you can see here I have declared 4 integers, signed integers under Linux Ubuntu 22.04. Size of an int is 4 bytes. So here it is 4 bytes. You can refer to my videos 69 and 70. 69 8 minutes 3 seconds. This video is in English, and video number 70 7 minutes 14 seconds. This is in Hindi. There you will find I have mentioned 4 byte integer, signed integer. Biggest positive integer which can be represented is this one. So this number is less than this, 5 lakhs. S3 is 5,000. S4 is 50,000. Now you can see I am writing this expression S2 star S3 divided by S4. Everything is integer, so division would be integer. Similar expression, logically identical expression, S2 divided by S4, as I have talked in the previous slide. S2 divided by S4 multiplied by S3. So both of them should give you the same result. But what is happening? This result is negative number. Whereas using calculator or your manual calculation, you will find that the correct result has to be 50,000. How come this? Let me tell you. Now here, since multiplication symbol, multiplication and division, both operators have the same precedence, but they are left to right associative. So this star would be, that is multiplication will be done first. So S2 multiplied by S3. So S2 is 5 lakh multiplied by 5,000. What is that? 25 lakhs, then 250 lakhs, and so on. So you add this, add these zeros, so you will get 25 followed by 5 plus 3, 8 zeros. So 25 followed by 1, 2, 3, 4, 5, 6, 7, 8. So 25 followed by 8 zeros is a number which is bigger than this. So this is the biggest positive number which can be represented. So most significant bit becomes 1 and so on. So number would be represented in 2's complement form. It becomes negative number. This is referred to as overflow. So it is giving you the wrong result. So negative number divided by a positive number, result would be negative. So it is like this, isn't it? Whereas in this case, I have divided it to make it smaller. So 5 lakhs divided by S4. So what is the result? 10. These 4 zeros will cancel, and 50 divided by 5 would give you 10. Now 10 multiplied by S3 is 5,000. So 10 multiplied by 5,000 is 50,000. So this is the correct result being printed here. So don't learn programming only for sake of learning. Your aim should be to solve the problem. And you have to be very careful about precedence of operators and their associativity, as well as the size of the data you are operating on and their values. If values go beyond certain limit, it would be overflow. You may get results which cannot be guaranteed, which cannot be verified. And if these numbers are very small, in case of floating point numbers, it may so happen that the result is very small, but it is not 0, but it is a number which is less than the smallest number which can be represented using floating point representation. So there again it will give you the unpredictable result. So be careful and use the expressions, write the expressions appropriately. Be careful about the associativity and precedence of various operators. This program we have just seen. And what would be the next? In the next video, we'll study branching and decision statements. And first one in the list would be nothing but the if else. So let's see in the next video. That is all in this video. Thanks for watching.